Hi, today I will be building a smart automatic door systems used on the Tinkercad. So this project is an automatic smart door systems designed for hands-free access control using an Arduino. By using an HCSR04 ultrasonic sensors, the systems measure the distance of the object in real time. When an individual, such as a person, comes within the 100 cm range, the Arduino will trigger the servo motor to rotate 90 degrees, simulating the opening of the door. So the current distance is continuously updated on the 16x2 LCD display and the serial monitor for monitoring process purposes. This setup serves as a fundamental models for touchless entry systems, improving both the accessibility and hygiene in modern smart home applications. So this is the component requirements. We need one Arduino Uno, one long breadboard because we need to put a lot of sensors on top of it. So this time we will use a longer breadboard, and one LCD times 2 display, one ultrasonic sensors, specifically the HR04 HCSR04 ultrasonic sensors, the micro servo motor, and 1 kilo resistors, and 1 potential meters, and some jumper wires. So for the prototype, we need to first connect the LCD displays to the Arduino Uno. We need to connect both the VCC and ground to the ground and the 5-volt rail of the on the breadboard. And we need to connect the V0 to the middle of the potential meters and connect the left pin and the right pin of the potential meter to both the 5-volt and the ground. And the RS, we need to connect it to the one of the digital pin on the Arduino Uno. For here, I'm connecting to 8. And the RW connects to the ground, as you can see here. And the E, we need to connect also to the digital pin. Here I'm connecting to 9. And we'll start connecting the pins, the next few pins from DB4 all the way to DB7. For me, I'm connecting it to the digital pin 10 all the way to 13. And the LED anode, we have to connect to the 5-volt. And the LED cathode, we need to connect it to the ground with a 1 kilo ohm resistors. So for the ultrasonic sensors, we need to connect the power and the ground to the 5-volt and the ground on the breadboard. And we'll connect the trigger pin to the digital pin and also the echo pin. For here, my trigger pin is connected to 3 and echo is connected to 2. For the micro servo motor, we need to connect power and ground, of course, to the 5-volt and ground. And the signal pin, we need to connect to the digital pin also. Mine is connecting to 4. For codings, we need to first include the library for both servo motor and LCD display. And next is to configure the LCD displays pin. From here, since I'm connecting from 8 to 13, I'll put 8, 9, 10, 11, 12, and 13 pins here. And we need to start the servo motor object. Here I'm naming it my servo. Okay. Now setup sections. First we will define what pin is connecting to the servo motor. And next we'll start the serial monitor by putting serial begin 9600 baud rate. And here we need to define both the trigger pin and echo pin for the ultrasonic sensors. Trigger pin is output, echo pin is input. Okay. And the LCD display, we need to set it to begin with the 16x2 layout. And we need to ensure the servo motor is starting from 0. So we'll put the name of the servo motor object and write it as 0. loop sections here, we need to put long duration and distance first for the ultrasonic sensors. And next we will digital write the trigger pin as low and delay 2 microseconds. After that, digital write the trigger pin as high, so it will send out an ultrasonic sound wave. And after 10 microseconds delay, the trigger pin of the ultrasonic sensors will be set to low. Duration is equals to pulse in. The echo pins will set as high, and the distance will equals to the durations time divides 0.034 times 2. So this is the equation for measuring the distance. So if the distance is less than 100, the servo motor will rotate 90 degrees, indicates that the door has been opened, or else the servo motor will be 0 degrees. Okay, here we will print the distance in the serial monitor, and next is to print the distance on the LCD display, and followed by the last section, which is the delay 1 seconds, which is 1000 milliseconds. And we'll start the simulations first. So here, now we are over 100 cm. The motor won't be turning, but if we go near like below 100, the motor will be turned to indicate that the door has been opened. Okay, so this is the project for smart automatic doors.